Hello students, in this video we will analyze two important trigonometric limits. We're going to show that the limit as x approaches 0 of sine of x over x is equal to 1, and that the limit as x goes to 0 of 1 minus the cosine of x over x is equal to 0. These limits are very useful in showing that sine and cosine are differentiable functions. So how do we do this? Let's draw our unit circle. It's important to realize this is important geometric characterization. So here's our unit circle. So this is our unit circle, x squared plus y squared is equal to 1. And I'm going to pick an angle over here. I'm going to pick an angle over here, x, okay? And so if that angle is x, then this length right over here on this right triangle, that length is just the sine of x, and this length down over here is going to be the cosine of x. Okay, excellent. And therefore, this little length over here is going to be 1 minus cosine of x. So that's what that little tiny length is over there, okay? Now, by definition of radian, I know what? I know that if I look at the length of this arc over here, the length of this arc is equal to x. So that arc length is x because the angle is x and we're on a unit circle. So from this I can see that sine of x is less than or equal to x. Now I can draw another triangle over here. So let me do this. I'm going to draw a tangent line up here. Let's draw a tangent line. So here is a tangent line. That's a tangent line. I'm going to connect that triangle right over there. And so now I have this larger triangle over here. So this triangle right here is also a right triangle because it's a tangent. And I want to know what this length is over here, L. I'd like to figure out that length, L. So what is L over here? Well, I know that this triangle, this right triangle, that green right triangle, is similar to this original triangle we drew over here. So I know that the ratio of L to sine, so L to sine by similar triangles, we know that the ratio of L to sine of x, that length over this length, has to be equal to the ratio of the length. So I have a 1 over cosine. So this is equal to 1 over cosine of x. So therefore, what is that L? What is the length of that tangent line? The length of that tangent line is just tangent of x. Pretty cool. So L is tangent of x. Okay, excellent. And so we see from this we get a chain of inequalities. We get the chain that the sine of x is less than the tangent of x. So we get that chain of inequalities from our triangles over here. Now I'm going to divide everything by sine. So I divide everything by sine of x. I'm going to get 1 is less than x over sine of x. And if I divide tangent by sine of x, what will happen? If I divide tangent by sine of x, I get 1 over cosine of x. And if I take the reciprocal of this inequality, what do I get? Taking the reciprocal flips the sense of the inequality. I get cosine of x is less than sine x over x is less than 1. Great. And so then what happens over here, as I let x go to 0, I can use the squeeze theorem. So as x goes to 0, limit as x goes to 0 of sine of x over x is equal to, well, cosine of x is tending to 1, and 1 is tending to 1, so this is equal to 1 by the squeeze theorem. By the squeeze theorem. Good, so that's our first result over here. Now our second result stems from an algebraic manipulation. So what I'm going to do with this 1 minus cosine of x, so 1 minus cosine of x over x. I'm going to multiply top and bottom by 1 plus cosine. And what will I get? So the numerator is going to turn into what? The numerator is going to turn into a 1 minus cosine squared of x, and the denominator is going to be an x, and then a 1 plus what? And then a 1 plus cosine of x. Now 1 minus cosine squared is sine squared. So this is going to be, I'm going to write it as sine of x times sine of x, just to be pedantic about it, over x, and then a 1 plus cosine of x. So algebraically, our expression, 1 minus cosine x over x, is identical to this. Now let's look carefully. If you look at this carefully over here, I can use limit laws, because this limit over here, we just proved that that limit tends to 1. This approaches 1 as x goes to 0. And as x goes to 0, what does this converge to? As x goes to 0, this goes to 0 as x goes to 0. So the limit as x goes to 0 of 1 minus cosine x over x is going to be 1 from the sine of x over x times 0, so that limit is equal to 0. So again, these two limits pop up when we're trying to study the differentiability of sine and cosine, so these limits are very important to know. Thank you very much.